creatures made of physical things can have preferences, goals, behaviors, and so on. Bioelectricity is one way in which here on Earth we can see the scaling of goals, from little tiny goals that individual cells have to very large goals that organs and then of course whole bodies have. So bioelectricity is very important, but it's just one particular way that happens. And there were actually several books. The very first book that I encountered on this was a book by H.S. Burr, Harold Saxton Burr. And this guy worked in the 1930s and 40s. He basically had the first good voltmeter. And he went around measuring everything, plants, rabbits, tumors, patients in psychiatric institutions, everything he could manage. And on the basis of this, he wrote a remarkable book. I think the guy had a crystal ball. He foresaw, with this very simple technique, many of the things that we've discovered since then. Just amazing. But and so this made a huge impression on me. But not until I saw Becker's book did I understand that there was actually a considerable body of work after Burr. Burr's book came out in, I think, 1936 or something like that. And what's amazing about The Body Electric, which is Robert Becker's book, is that he talks about a lot of the people that have done work since then. So all the greats of early bioelectricity. And on reading that book, it became obvious to me that this was an actual field that could be pursued now. Now also that book has, half of the book is about electromagnetic dangers of field exposures and things like this. And I'm not really into that. I think that doesn't actually have anything to do with bioelectricity. I think that was kind of a red herring, really. But the part where he goes over how it is that electricity is the basis of embryonic development, regeneration, cancer, this really, kind of put me on the path that's an entry point to studying the things I really want to study.
Goes to a whole bunch of carcinogens in our everyday environment. Many of the synthetic chemicals that are now manufactured for a wide variety of reasons are carcinogenic. But underneath all of this, I think that there is another factor which, whether or not it's going to turn out to be the most significant, most important factor, I think it will be one of the most important factors, and that is the electromagnetic environment that we're living in today. Of all of the changes that man has made in his environment through technology, the biggest change of all has been one that we cannot sense. There's no way we can tell with any of our senses that we have so changed the Earth's, the global electromagnetic environment, that it is the most massive change of all. It's far beyond any greenhouse effect or ozone hole effect or water pollution or soil pollution or what have you. This has become a massive global alteration that was done without a thought, without any evidence that there would be any harmful effect.
Well, we'll get to that, friends. It's time to pause for another back with all the birds and all. Dr. Becker, sorry to break in on you there, but
that's okay.
We had to.
That's okay. Let me just recap what I said. That is that for 2.5 billion years, living things, humans included, lived in a certain electromagnetic environment, a normal global EM environment. And only within the past 50 years have we made these massive changes in that environment. And it's over that same period of time that we have begun having the problems with our medical care system, with what appears to be epidemic types of cancer that are appearing at the present time. I think there's a very definite connection, and I believe that connection should very certainly be looked at. Now, on the other side of the coin, the evidence is rather clear that abnormal, man-made electromagnetic fields do influence the operation of the genetic system when cells divide. They do influence the rate of division of cancer cells. They speed it up enormously. Now, if it has these kinds of effects, is it not possible that we could look at the whole range of effects of electromagnetic energy and the growth of cancer cells or the origin of cancer cells, and possibly arrive at a position in which we could say, well, this kind of electromagnetic energy can cause a cell that has become cancerous to revert back to normal. And it's my opinion that this is a very feasible approach. And
editor for the Journal of the American Medical Association. Professor Pash and his colleagues have developed a novel treatment that uses very low-intensity radiofrequency electromagnetic fields to target specific types of cancer. The device, known as the Therabionic device, uses two waves, a carrier wave set at 27.12 MHz and a modulation wave that is specific to the type of cancer being treated.
We initiated this research in 2001, and after a couple of years we were quite surprised to find that the same modulation frequencies were found over and over in patients with the same type of tumor, irrespective of their gender, their age, and their ethnic status. So it suggested early on by 2003 that tumors might respond to some specific frequencies.
The researchers used biofeedback in order to determine the frequencies that correspond to each type of cancer. Variations in the patient's pulse were measured as they were exposed to a range of different modulation frequencies. The results showed that people responded to specific frequencies depending on the type of cancer. Electromedicine involves the use of frequencies, and the results are not dependent upon a higher intensity. In fact, in many cases, very low-intensity electromagnetic fields produce the best results. The specific absorption rate, or SAR, is often used as a measure of the amount of radiofrequency electromagnetic energy absorbed by the body when a particular device is being used. For example, Apple's iPhone 6 has an SAR of around 0.9 to 1.19 watts per kilogram.
Actually, a very good point. So far, as is published, our SAR levels have ranged from 0.03 all the way up to 1 milliwatt per kilo. And we've found that in that range, there is no difference in the outcome, which is the anti-proliferative effect, which means that it's potentially it's not limited to the dose, but rather there's something specific about the frequencies that we're using, regardless of dose, if you will, or the SAR.
So not only are there a wide range of exposure levels that seem to have an effect on cancer cells, but the exposure levels associated with this effect are also less than 1/1000th of the exposure typically generated by a mobile phone.
I'm Dr. David Baskin. I'm a professor of neurosurgery here at Houston Methodist Hospital and Weill Cornell College of Medicine. I'm the residency program director, I'm the vice chairman of the department, and I'm also the director of the Brain Tumor Center. So it's a great privilege to speak at the American Academy of Neurosurgery. This is kind of the premier organization. It's an opportunity to present to academic neurosurgeons, people who are creative, thoughtful, inventive, get some interactions back and forth. We know that cancer shifts its metabolism. Otto Warburg won a Nobel Prize many years ago discovering what's now known as the Warburg effect, which means cancer, instead of using glucose and glycolysis, shifts to utilizing the mitochondria to make energy through the electron transport chain. A byproduct of that is reactive oxygen species are let out of the chain. These reactive oxygen species, called ROS, are mainly superoxide and hydrogen peroxide. So we know that cancer cells, if you just take any cancer cell and you measure the ROS, it's much higher than in normal cells. That's the consequence of this shift in metabolism. So I'm honored to present our work on oncomagnetics. It's a word we invented here at Houston Methodist Hospital. We developed this technology where we use oscillating magnetic fields to take these electrons that are traveling down the chain and try to knock them off the chain so the level of ROS would get so high in the cells that it would be toxic and kill the cells. So it was kind of a crazy idea. We spent a long time in the laboratory with cells from patients taken from the OR and grown in our laboratory. We've done this work in cell culture. We've done it in animals implanted with glioblastomas and seen tumors shrink away. And now we've actually done it in humans and seen some dramatic results. So I'm privileged to be able to talk about this with my colleagues, and I'm hoping to learn as much or more from them than whatever they might learn from me.